achievements of Anastasi, and it's an incredible honor for me to be welcoming you to this lecture this year, because it's the 100th anniversary of the Graduate School of Arts and Sciences, in which, in whose history Anastasi was a very, very important figure. So I'm going to allow myself to tell you a few words about the school and its centennial, and then a little bit about Anastasi. So the school was founded 100 years ago, not quite yet to the day. It was November 1916 when GSAS was founded. Its first location was the Woolworth building downtown. At that time, it was not just the tallest building in the city, but actually the tallest building in the world. We were on the 20-something floor, so high up for those years in the sky. I still, admire the brave souls who came to study at the Graduate School of Arts and Sciences at Fordham, a school that did not exist a month before. There were 4 professors, 3 of them Jesuit priests, and 1 of them a lay person, all 4 male. There were 8 seminars, primarily in the traditional disciplines of arts and sciences in a Jesuit school, so most of them in philosophy, English, and theology. There was obviously no department of any kind, not even of English or classics, much less obviously psychology, because obviously psychology was also a very young discipline at that time. So we had very, very small beginnings. President Woodrow Wilson turned on the light switch in the Woolworth building when the building went up in 1913, so just 3 years before the graduate school moved in. But there are a couple of things to highlight about those beginnings, some that I really take pride in. We were co-educational right from the very beginning, and welcoming both to female students and eventually to women professors and women scientists, of which Anastasi was one. In the first cohort of graduating PhDs in 1921, there were actually two women PhDs who graduated, one in English, one in philosophy. And that sort of tradition of openness really continued. I think, because of the holiday today, it's also interesting to highlight that the school was very welcoming to refugee scholars in the 1930s. There were some refugee, there was a refugee philosopher, a very famous one, and a physicist who came from Germany, escaping the Nazis, and they became professors, very influential ones in the Graduate School of Arts and Sciences. So there is that tradition, and when we were preparing this year to celebrate the centennial of GSAS and sort of looked back over our history, and Anastasi really stood out as a kind of pillar of that history for us. So now I turn to telling you a few words about Anastasi. As you all know, because you're in the discipline, you share with her. She was an American psychologist best known for her pioneering work in psychometrics, which earned her the really unforgettable title of test guru. Her research focused on issues related to test construction, test misuse, test misinterpretation, and cultural bias. She argued against the strictly hereditary argument on trait formation and emphasized the role of experiential, environmental, and cultural influences on test scores. She had more than 150 publications, including the very influential textbook on psychological testing, which was published by Macmillan in 1954. It's interesting, however, to look at some vignettes of Anastasi's earlier formation, earlier life, given these unprecedented achievements. Anastasi was the only child of a Sicilian immigrant family in the Bronx, so even her beginnings kind of put her close to our location. She was schooled at home by her grandmother and a tutor until age 9. Her father died when she was only 1. She had a very enterprising and practical mother who kind of took on the resourcefulness that was needed to support the family. And this early training instilled in Anastasi a boundless intellectual curiosity, and possibly gave her, what some might say, a happy unawareness of gender stereotypes when it came to schooling. When she entered public school at age 9, she was moved several grades ahead. But her high school experience was, by contrast, really quite disappointing. She dropped out after just 2 months. When I was reading some biographical experts, some of them actually autobiographical experts, she was saying that the school was too run down and the academic standards were not up to her own standards. So she soon learned that Barnard College did not require a high school diploma for admission, so she spent 2 years preparing, mostly on her own, for the entrance exam, and then gained admission to Barnard at the age of 15. She was hoping to major in mathematics, but lectures with Harry Hollingworth sparked her interest in the then young discipline of psychology, and she ended up majoring in psychology. She graduated from Barnard in 1928 and went on to study at Columbia, and then received her PhD at the ripe old age of 21. The formative experience of those years was probably the research assistantship that she held with Charles B. Davenport, who was working on what were then called culture-free tests. Which she then obviously went on to question. She also had the opportunity to attend the International Congress of Psychology at Yale, where she met Charles Sperman and the Russian physiologist, someone by the unknown name of Ivan Pavlov. In 1933, she was diagnosed with cervical cancer, and the treatment left her sterile. And I'm telling you about this because it's an interesting comment on the position of women in academia in the 1930s, that she apparently believed that this contributed to her professional success, since it freed her from conflicts around motherhood. After graduating with a PhD, Anastasi held teaching positions at Barnard and Queen's College, where she actually became the department chairperson. She came to Fordham as an associate professor of psychology in 1947, was promoted to professor in 1951, and remained here until her retirement. In 1972, Anastasi was recognized for her accomplishment and elected president of the American Psychological Association as only the third female president in the organization's history. In 1987, President Ronald Reagan presented her with a National Medal of Science, the highest award for scientific achievement in the US. Other recipients of that award in her category included the likes of B.F. Skinner. She was named the most prominent living woman in psychology in the English-speaking world, but was said to have been really uncomfortable with that designation, insisting that she was simply a psychologist and not a woman psychologist. As usual, the full picture of a person does not emerge without a glimpse behind the scenes, and for that we can rely on our own colleagues here at Fordham. Her colleagues here knew her for a certain, shall we say, indifference, the more practical aspects of daily life. And I will quote this anecdote because it's so entertaining in full. So once Dr. Mary Prosidano said she heard a shriek coming from Dr. Anastasi's office. Running to see what was wrong, she found Dr. Anastasi trying to pry a plug out of an electrical outlet by using a metal letter opener. "Did you get a shock?" Dr. Prosidano asked. "How fascinating," Dr. Anastasi replied, letter opener in hand. "How did you know it was a shock?" Professor Anastasi retired from Fordham in 1979, at which time Fordham also conferred on her an honorary Doctor of Science degree, and she died in 2001. But now I turn to the person who inherited her title, Professor David Budescu, who is sitting right here, and is the first holder of the Anastasi Professorship of Quantitative Psychology and Psychometrics here at Fordham. The prestigious chair was inaugurated in 2009 with a bequest created in the name of Anastasi to enhance her legacy at Fordham. Our president, Father Joseph M. McShane, said on the day of the inauguration that Anastasi was a force of nature whose generosity continues to put Fordham in the first ranks of psychology to this day. Following the inauguration, Professor Budescu gave the first Anastasi lecture, focusing on a decision theoretical perspective on psychometrics, analyzing test-taking behaviors, and he's clearly following in Anastasi's footsteps. And as you can see, the tradition of the Anastasi continues. It's an annual lecture, but it also continues with the incredible achievements coming from the holder of the chair, who, as you may know, received the 2016 Exeter Prize for Economics this year. So it's my great pleasure to welcome David to introduce our speaker today.
Thank you for the kind words and introduction. I've learned a lot about Anastasi. That's one reason to do it every year. But it's my pleasure to really, first of all, welcome all of you, and then to introduce our speaker today, Barbara Mellers. Barb is the I. George Hyman University Professor in Marketing and Psychology at the University of Pennsylvania. She's also one of a handful of Penn Integrates Knowledge Professor, which is a special designations for researchers with positions in multiple departments and help interdisciplinary, interdisciplinary work. Let me tell you a few words about Barbara. She has a bachelor's degree in psychology from Berkeley, and then she has a graduate degree from University of Illinois in quantitative psychology, where she worked mostly with Mike Birnbaum, and those of you who know the JDN literature know their joint papers. And over her career, she had, and tell me if I get the sequence right, psychology at Berkeley, psychology at Ohio State, then back to the business school at Berkeley, and for the last 6 years at Wharton and Pennsylvania, this joint appointment. Her own description is that she examines the factors that influence judgments and decisions, including emotions, self-interest, past mistake, sensitivities to risk, and perception of fairness. And we send some to you a long and convoluted sentence, but every single word there is true, because she has done important work in each one of these areas. For the last 5 or 6 years, Barb, together with Phil Tetlock, are heading the Good Judgment Project, which is, you're going to hear a lot about it in a few minutes, and which is work about forecasting. And I don't know exactly who and when the term translational research was coined, but I cannot think of anything which is more prototypical of what translational research is than the Good Judgment Project, namely building upon the theoretical foundations in psychology and in other social sciences in order to apply and to solve applied problems in the context of real world, while being sensitive to the constraints of the situation, and at the same time, not only solving problems, but also refining and advancing theory. So I've known Barb for many, many years, and we agreed not to try to count how many, but knowing her work, and knowing her status in the profession, I can tell you that she has the universal respect and admiration of everyone in the JDM community, both for the wonderful work she's done in all these areas, and also for being, a pillar of the society and of our area, and her integrity, and of course her good judgment. So please welcome, Bob.
See, this is one?
Yeah, I think it's
All right. Can you hear me back there? Yeah. Okay, wonderful. Well, thank you, David. That was very kind. I have known David forever, I think, and yeah, I don't even want to count. It's way too long. Okay, well, the story that I want to tell you this evening is one that I could not have told without the help of thousands and thousands of people. Some of them are sitting here in this room. Pavel Atanastov, Regina, Eva, Chen, David Budescu, and These people took part in the Good Judgment Project in a variety of different ways. One of them's a Superforecaster, one of them's a staff member, postdoc, and David was a collaborator with us as well. So it's a treat to tell you about this story tonight, and thank you so much for having me. Let's see. Okay. Making forecasts is planning, anticipating, predicting, is an integral part of being human. And let's see here. It's very interesting. All right. And the way that we usually do it is in terms of verbal uncertainty phrases. What we do is essentially to say things like there's a fair chance that something will occur, it's likely that an event will happen, and we use these terms. There's a remote chance of something, an event occurring. We use these terms both in our personal life and our professional life. Now, see? I'm doing something wrong here.
Could happen.
It could happen that it'll work, yeah. Then again, all right, we'll do it this way. An example of vague verbiage in forecasting. To find one, you don't have to look very far. Here is the World Economic Outlook from October 2014. And if you read any arbitrary sentence in this pamphlet, you'll find something like this. There is a risk that the recovery in the euro area could stall, demand might weaken further, and low inflation may turn into deflation. All right, see how we do it? If you count up the number of times you find the word could in this pamphlet, it's 120. The word might shows up 15 times and possibly shows up 6. So we do it all the time in our professional lives. We do it all the time in our personal lives. And the question is why? So let me take a stab at this question and let's see, give you 3 reasons why. First of all, it's much simpler than making numerical estimates. It takes much less mental effort, much less cognitive load, and who wants to put the effort into precise forecasts when the stakes aren't all that high? It's also the case that it's easier to stay on the right side of maybe and harder to be blamed for a bad forecast. So if you say something's likely to occur or it's possible that it might occur, well, you haven't necessarily made a bad forecast, have you? You said it could occur, and it's quite ambiguous what that means. So what's wrong with this? Excuse me. And the third reason, sorry, is that such terms convey less precision. And in some situations, I think that can be a very good thing. It would be extremely strange if your spouse came home and said to you that there's a 17% chance that he'll go to the Halloween party with you, an 8% chance that he's going to blow up at you this evening, and a 5% chance he won't like the dinner that you cook. It just doesn't work, does it? So verbal terms convey a certain amount of expertise and knowledge, and they're very easy to use. So what's wrong with it? Well, one of the people in this room, David, has done some beautiful work on some of the confusion that goes on with verbal terms. Here is a graph showing plausible estimates of verbal uncertainty phrases. There are a few, as you can see here, that are pretty certain. We all agree what it means to say something's a slam dunk or a sure thing. We also agree on what it means to say something's impossible. But the rest of these terms have quite a wide range of interpretations, numerical interpretations. A real possibility goes from, about 20% to about 90%. A risky option, or let's say a distinct possibility here, just about as wide. So there's an awful lot of meanings that we could infer from verbal probability phrases. That's one problem. There's another problem that I think is even deeper, and Bill Gates happened to talk about this problem in an op-ed piece he wrote for the Wall Street Journal about a year ago. What he said, he was writing about a book he'd read called The Most Powerful Idea in the World by William Rosen, and it was about the invention of the steam engine. Okay. Oops. And he wrote, harnessing steam power required many innovations, and among the most important was a new way to measure the energy output of engines using a micrometer. This was a little device also called the Lord Chancellor that could gauge tiny distances. Such tools allowed inventors to see if their design changes led to improvements. And after that, he said, I've been struck by how important measurement is to improving the human condition. You can achieve incredible progress if you set a clear goal and find a measure that will drive progress toward that goal. Well, that was exactly the mission that IARPA had. IARPA is the research wing of the intelligence community, the little sister to DARPA. And they had the goal of coming up with a competition to improve human forecasting of geopolitical events. And let me give you a picture of what this was like. This was a tournament that went on, well, 4 tournaments that went on between the years of 2011 and 2015. Here are some example questions. Forecasters were given 500 or so forecasting questions over this period of time. And one of them might be between March 18th and June 1st, 2015. Which country or countries will officially announce that it or they will join the Asian Infrastructure Investment Bank? Okay. So all of these questions were of interest to the intelligence community, and forecasters logged on from all over the world on a website where they made predictions about each of these different events. Now, there were 5 competing university groups that used, essentially, it was a level playing field. They used the same measure of accuracy, the same forecasting questions over the same period of time. And the beauty of the forecasting tournament is that you test multiple things all at once. So you speed up the scientific process. Okay, so the goal was to discover the most accurate possible way to elicit and aggregate forecasts from a large dispersed crowd, And the measure of accuracy, or the measure to drive progress toward that goal, was the Breyer score. Let me give you a little example of how the Breyer score works. It's a squared quadratic loss function. So here's an example of a meteorologist who's predicting rain for 4 days. On the first day, it says 90% chance of rain, and it rains. Second and third day, he says 50%, it rains, and then the third day, 50%, it does not rain. Fourth day, 80%, and it rains. Now, the way you score this meteorologist is by using the 1 or 0 for the event that occurred or did not occur, and you take the deviations between what occurred, 1 or 0, and the forecast associated with that. So 1 minus 0.9 squared plus 0 minus 0.1 squared. So his Breyer score on day 1 is very small, 0.02. All right, you run through this all 4 days, take the average, and the meteorologist's Breyer score is 0.28. So what does 0.28 mean? It means pretty good. Now, Breyer scores are best when they're low. So 0 is a perfect score, and 2 is reverse clairvoyance. Yeah, I think of this friend of mine in Berkeley who recommends movies for me on a regular basis, and I know whenever he recommends a movie that I'm absolutely going to hate it. Yeah. So he's a perfect predictor of movies not to go see, and that's what I think of when I'm looking here at 2. All right, chimps randomly tossing coins somewhere in the neighborhood of 0.5. So this is the range of scores, and the goal now is to drive progress toward 0. Okay. So how did we do that? Well, we had forecasters make their judgments, probabilistic predictions of events, geopolitical events in the world. Here's an example question: who will be inaugurated as president of Russia in 2012? This was posted September 1st, 2011, and closed on May 14th, 2012. Now, it may seem strange at this point in hindsight, but this actually was a question with some degree of uncertainty. We plotted forecasts from September 1st all the way over to May 14th, and kept track of what people were saying. And what's on here, these different lines represent different methods that we were using: prediction markets, surveys, different methods of aggregating forecasts, and what they are is not really important. The prediction market, the black line, is the one that's going furthest down, and it's somewhere in the range of 0.7 down there. So there was some uncertainty about this at the time. We didn't know that it wasn't really an election at all, but that's just another story. So what happened next? We're using 4 drivers, which I'll explain in a few moments. Our team, the Good Judgment Project, won the tournament each year for 4 years, and we showed that our best method was about 60% more accurate than the mean of the control group or the unweighted crowd. How did we do this? Well, these 4 drivers were identifying the right people, training them in probabilistic reasoning, using teams versus working alone, and tracking the best forecasters. Finally, the fourth driver was developing simple rules for aggregation of survey results in this case. Let me go through each of these in a little more detail to give you a sense of how we did this. Now, when we started this project, we really had no idea of whether there was such a thing as forecasting skill or not. And we don't think anybody else did as well. This figure that looks like recordings from a seismic machine and in some dangerous place is evidence that there really is such a thing as forecasting skill. Now, this graph comes from about 800 forecasters who participated in the first 2 years of the tournament. What we did here was to standardize their scores and then take the very first 25 questions and compute an average Brier score for them. Then we put the worst 100 people in one group, that's the gray line up top, and the best 100 people in another group, that's the black line down below. And you can see they started out, roughly speaking, about 1 standard deviation apart. And the question is, what happens to these two groups for 175 extra questions over time? So it's kind of interesting. The worst group, the gray line, continues to be the worst group, all the way up to the 199th question. And the black group, the best one, continues to be good. Remember, lower Brier scores are better. All the way up to the 200th question. And there's about a half a standard deviation apart in the average scores of these two groups at the end. The reliability score, the correlation between forecasters' scores in year 1 and year 2 was about 0.7. So we had a fairly good, stable something here that we interpreted as forecasting skill. So what were these people like? Well, those who tended to be the most accurate had greater knowledge, political knowledge, and they also scored higher on tests of fluid and crystallized intelligence. Now, you might say, well, that's kind of obvious. Wouldn't you expect that? And I'd say, well, it turns out that in prediction markets, that is not what you get. There is no correlation between political knowledge and earnings in prediction markets. And there is no correlation between intelligence and earnings in prediction markets, which led us to consider the possibility of writing a paper called, "If you're so rich, why aren't you smart?" Okay, more about the most accurate people. They had a belief that subjective probability estimation was a skill worth cultivating. Growth mindset, a Carol Dweck approach. They did not believe it was an innate trait that either they had or they didn't have. They also took the view that the world was determined by scientific laws, and concepts like religion and fate had not too much to do with it. They also differed in their cognitive styles. They had higher scores on a test that, a psychologist at the University of Pennsylvania developed called actively open-minded thinking. And this is a very interesting test. It measures the extent to which you go out and search and use information that runs counter to your favorite beliefs. And last but not least, they had a strong competitive streak, and higher scores on need for cognition. They liked puzzles, they liked intellectual challenges, they enjoyed analytic thinking. Okay, the second driver was training. It was very helpful to teach forecasters a little bit, some practical tips about how to do forecasting. Where do you find some of the professional forecasts that are out there? How do you do it? Well, we told them to first consider reference classes and then consider specific information that's detailed and vivid and might take over your estimate. We gave them tips about averaging when they had multiple perspectives, extrapolating over time, and avoiding judgmental biases such as overconfidence, confirmation bias, and base rate neglect. So, this figure shows, this again is best, up there is worst, untrained and trained forecasters. These were randomly controlled trials with random assignment to conditions. So you see the effect here of training, which occurred each year for all 4 years in the survey conditions. Okay, we didn't know what the best social interaction would be for forecasters, so we put it to an empirical test. And we randomly assigned forecasters to conditions in which they worked alone, independently, and those in which they worked in teams of about 12, 15 people. And you can make cases for both of them. I thought the independent forecasters would do better. Their estimates are uncorrelated, the errors should cancel out. But in fact, the information sharing in teams was much more beneficial than errors canceling out. And so the regular teams were better than independent forecasters. And then the super forecasters who were tracked were even better still. Now, we define super forecasters as the top 2% of all forecasters in any given year. So each year, we had another pool of super forecasters. And we watched what happened to them over time. We thought if forecasting skill is real, we shouldn't see regression to the mean. Allowing these people to work together, sort of like tracking in school, putting all the smart children together in the same classroom, we ought to see a beneficial effect, not a decrease, regression to the mean. And that's exactly what we found. There was a huge effect of tracking super forecasters. And it worked each year for all 4 years. Okay. Some people, like David, I presume, would probably rather see forecasting expertise in terms of ROC curves. And I'll just go quickly. ROC curves show the probability of a hit, plotted against the probability of a false alarm, and curves that are closest up toward that upper left-hand point are the best curves. So the blue curve here, which represents super forecasters, shows a much higher D prime, which is another estimate of skill or ability. And these are other groups in the forecasting tournament. Super forecasters were best in a whole variety of measures, and ROC and Breyer scores are just two of them. Okay. Now, we also looked for aggregation rules that were fairly simple and intuitive, and there were several that worked fairly well, but one of them that worked the best over 4 years was a modified log odds rule. And here's what we did. We discounted older forecasts, so they'd have less effect. We computed, we transformed forecasts to log odds, and we took a weighted average where the weights were based on expertise, and finally, after transforming back again, we extremized the aggregate forecast. Okay, what does that mean? It means that if the weighted average was 0.3, we extremized it, so it was 0.1. If the weighted average was 0.7, we extremized it, so it was 0.9, which is like saying we have more signal than the average suggests. Well, what's the intuition behind that? It's really quite interesting. If you have, imagine you have 10 people, and you ask them what's the probability that Hillary is going to win the election. And all these people have been talking to each other and no one else. Now, if you take the average, you'll get 0.7. And 0.7 is probably a good estimate of the signal in that group. But now if you take 10 other people who have come from all over the country and have talked to completely different people, when you compute the average of their 0.7s, you probably have more information in that average than you would otherwise. That's the recalibration or the extremizing that's going on. We're pushing it higher to 0.9 rather than 0.7. So it's a transformation that has sort of a shape that's the inverse of the decision weighting function in prospect theory. Here, this graph illustrates the power of the modified log odds rule. The red bars show mean Breyer scores, simple means for the independent forecasters, the regular team, and the super teams. The blue bars show what happens after the use of this aggregation rule for independent forecasters, regular teams, and super forecasters. So the Breyer scores go way down, and I think part of the reason why you don't see the big effects for the super forecasters is because they were taking the transformation into account already. Now, I want to make a quick nod. Yeah?
Can I ask a question? All of the teams have the same number of people.
Yes, right.
Cut across the three people.
Excuse me?
Every team is the same number.
Yeah. At least they start out that way. Now, I'll just make a quick nod to Anastasi with a couple of papers that came from the Good Judgment Project. One of them is one by Eva Chen and David Podesco and others that proposes the contribution weighted model and tests it on the Good Judgment data. There are also a couple of very interesting papers done by Ed Merkel, Mark Stivers, and others on an item response theory approach to forecasting. One unidimensional underlying skill forecasting skill with problems along that dimension as well. Okay, so we learned a number of things from this experience, but I want to mention two of them. One of them is that this couldn't have happened without interventions that were both statistical and psychological. It was the combination that made this work. I think we usually think about forecasting as a statistical problem, but in fact, it's not at all. It's human behavior combined with statistical aggregation rules. The second lesson I want to mention to you here is that there was no single thing that made this boosted forecasting accuracy by itself. It was a whole lot of small interventions that, taken together, really added up to something. And it's a little bit like the Model T, you know, you take it and tweak it for many years, and eventually it turns into something quite wonderful. In our case, our forecasters, superforecasters, were more accurate than intelligence analysts who are working on exactly the same questions with access to classified information. Okay, I see I'm running out of time here a bit. You stop at 6:30? Go ahead. Okay, all right.
Never gonna leave.
All right, make sure you do. So this brings us to another question, which is, how do intelligence analysts go about making forecasts? Well, the answer is in a variety of different ways. They use qualitative verbal terms in written reports. They sometimes use quantitative methods, numerical estimates, and there have been some recommendations at different points in time to use different scales. Now, these are two category rating scales of uncertainty. One was proposed in 2007, the other in 2015. There's 7 distinctions on this probability continuum. And the upper one had equal numerical intervals, so 20% or 14% associated with each word. The lower one had unequal sized intervals associated with each of the words. And what are these numerical intervals for? Well, the user of the term is supposed to keep in mind what the numbers are that represent that term. So if you use the term very unlikely, that means you're somewhere in the range of 5% to 20%. Okay? So, with the good judgment data, we can ask another question, which is essentially, are these enough category distinctions on the probability continuum or not? How many distinctions do people actually make? Well, the way that there are many ways you can look at this. I'm just going to show you one. Here's data from years 2, 3, and 4 of the forecasting tournament. And I've plotted in ranges here the number of unique probability values that forecasters use within a year. So you can see that most people are in these 2 bins. They're using somewhere between 10 and about 30 distinctions on the probability continuum. Now that's for many questions, it's not for a single question. But it starts to suggest maybe there's something wrong with a 7-point category rating scale. There is another question then that is the following. How many distinctions on the probability scale do people actually need? And is a 7-point category rating scale enough? Well, you can tackle this problem with the data from the tournament in the following way. First, we computed everybody's Breyer score. we rounded people's forecast to the nearest, say, 10%, or the nearest 25%, and degraded those forecasts. We recomputed the Breyer score after degrading the forecast and examined whether there was a decline in accuracy from that degrading. And what you see is something quite interesting. Most all of the forecasters had less accurate Breyer scores when their forecasts were rounded to 7 distinctions along the probability continuum.
So their task was just a numeric point estimates, correct?
Yes.
Yeah, right. This is the analytic standard. This is what the intelligence, the best practices according to the intelligence community. What happened with the superforecasters? It was even worse. Their forecast became 40% less accurate with rounding to the nearest 7-point category rating scales. Okay, this is interesting. It suggests that within the intelligence community, the standard methods of expressing uncertainty with these 7-point category rating scales are simply not good enough. They are systematically sacrificing accuracy, not allowing people to make as many distinctions as they actually can make, and hurting the most accurate forecasters, the super forecasters, the most. So, how much accuracy are we sacrificing in other domains? Now, our results show, okay, that well, let me say it slightly differently. Our findings are based on geopolitical forecasting, and they might not carry over directly to other domains. But using verbal uncertainty phrases is something that's often done in discussions of climate change, discussions with our doctors, our lawyers. They're very commonly used in regulatory policies and a whole variety of different decisions. Now, our work gives essentially a template for addressing this question of whether we're giving people enough precision to maximize their predictive accuracy. It involves keeping score. It involves the use of this precise measurement tool, the Breyer scoring rule. It involves checking to see whether the predictive accuracy declines when you round those forecasts. And I think that if we did this, if we had this kind of data with doctors and lawyers and judges and many others, we find that predictive accuracy is indeed degraded with verbal phrases and 7-point category rating scales. Now, I thought that at least somebody would ask what the super forecasters thought about the election. And let me move along here. I looked on Saturday for the latest results from 538. Clinton was 68%, Trump 32%. Real Clear Politics said it was much closer, 48% to 42%. And the super forecasters said it was 77% for Hillary, 23% for Trump. Now, it's been a crazy election, and there's it's hard to know what's going on in the minds of the voters. It's also hard to know what's going on in the minds of of the candidates in some respect, but there's a lot of changes happening. There was one study that said Trump had changed his mind on 120 issues, or made 120 changes on 20 issues over a period of just 1 month. So no wonder it's a difficult election to predict, and we'll see soon what happens. Well, I mean, this may change tonight, right after the debate. So we'll see. Now, I want to mention something about tournaments, and it's that they essentially define a trade-off. Tournaments are only as good as the questions that are being asked. And so to implement tournaments in life, we need the skill of asking good questions. Now there's a rigor-relevance trade-off with questions. We want questions that are rigorous, they're grounded in the nitty-gritty, what's inflation this quarter, but we also want bigger questions that are relevant. Will Europe move toward tighter political integration or not? And the more we go for relevance, the less likely it is to be able to precisely resolve the questions that we want to ask. So one idea that we have used to solve this problem is to create question clusters. The idea here is you have multiple small indicators of a bigger event that you really care about, and with well-designed questions. Let me give you an example of one of them. You can do a lot to give yourself both relevance and rigor. You might have the question about China. Will China become more aggressive toward the US within the next year? Well, there are a number of different questions you could ask to get at that big question that you can't resolve, because what does it mean to say be more aggressive? I haven't defined it, right? So there's not a clear-cut right or wrong answer to that. But there are many small questions that tell us quite a bit about what's going on. So let me wrap up here and put tournaments in perspective. I think tournaments have a lot of important uses. I've shown you the scientific function of tournaments that essentially create a superpowered, speeded up scientific process of inquiry, where you can look at multiple interventions and methods all at once. Tournaments also have economic functions. Firms can identify super forecasters, super methods, and what firm wouldn't prefer to make better predictions. There's also an interesting societal function, I think, of tournaments, and it's this. They create something that's rarely seen in politics, and that's a pure accuracy game. What happens when people engage in forecasting and they're really competitive and they really want to win is that they have to focus entirely on accuracy, on truth. And if they have biases and mistaken heuristics that they're using, they've got to drop those in order to be the best. And that process of focusing exclusively on accuracy has a very interesting effect. I think it increases, this is a hypothesis, but I think it increases actively open-minded thinking. Now here is a plot that shows you different scores. The final measurement of actively open-minded thinking that we took at the very end of the tournament, minus the initial actively open-minded thinking score that we took when people entered the tournament, and it's shown as a function of the number of years in the tournament. There's a nice, interesting correlation here. The longer you're in the tournament, on average, the more actively open-minded you become. So this is a wonderful possibility for opening closed minds and perhaps reducing political polarization, and I think it's worth a try to find out if this could help our situation. So let me sum up here with a couple of thoughts. We know a lot more than we did 10 years ago about how to make accurate forecasts. And some methods are just demonstrably better than others. Now, the Good Judgment Project identified 4 drivers that push predictive accuracy down toward a 0 Breyer score, and they're identifying the right people, educating them, training them, putting them in teams where they can benefit from the help of others, and tracking them, of course, too, finding the best and putting them in separate classrooms with children like themselves. And last but not least, there's a tremendous benefit from using simple, clever statistical algorithms that aggregate forecasts from multiple forecasts. Now, we were also capable of asking the question of how much precision is necessary in forecasting. And in this case, we have pretty strong evidence that the intelligence community is not using enough distinctions on the probability continuum or the category rating scale for forecasters, the very best, to express the knowledge they actually have. That's a pretty easy way to fix predictive accuracy. That seems like a no-brainer to me. So the world's a messy place, there's no doubt about it, and it's difficult, very difficult to make accurate forecasts. But when the stakes are high, there's billions of dollars and thousands of lives, even a small increase in predictive accuracy can have enormous effects. And I'll stop here. Thank you. Questions? Yeah?
Thank you so much. This was a really nice presentation. What a cool project with so many applications and implications. I'm so jealous.
Thank you.
I had a couple of questions. One, the first one is,
Was every question that was asked then quantified into a dichotomy, like a yes/no question, and then people were tested against the actual occurrence of the event?
Well, every question had categories of responses. So I think the highest one was 5 possible categories, and they might refer to candidates in an election, time periods. So some of the questions were conditional. The U.S. does that. What's the probability of that? Those were often binary. So there were a variety of different questions, but they could all be scored with Breyer scoring rules.
And the second question is, have you been quantifying the amount of time spent by superforecasters versus the less superforecasters on the topics that they're working on?
Oh, the superforecasters were absolutely phenomenal. I can't believe we had these wonderful people who were so smart and so wonderful, working so hard for us. One guy who was a retired programmer from IBM learned that his wife was going to divorce him if he didn't reduce his time on the computer to 2 hours a day. 2 hours a day. So he's a programmer. What does he do? He writes a program to figure out how to best use his time by thinking about questions for which there's dispersion, variability in the forecast, questions for which people haven't updated for a long time, multiple cues. Well, this guy had the top Brier score of thousands of people that year, and he shared the tool with his teammates. And I think they not only had the top Brier score, but they came in second, third, and fourth, or something close to that. So this tool paid off. And how many of you can imagine your subjects writing a program to solve a problem that, needs a program to solve, So yeah, they were phenomenal.
So more time and better strategies make you a better forecaster.
There's a huge motivation component to it. That's not all. There's also this enriched environment in which they're working. They're actually becoming good friends. There's also some talent that's underlying this process. And yeah, I'd say it's all of those taken together that give you this amazing talent that is so important to demonstrate in at least one domain. And I think it would be a noble effort to spend your life trying to find super forecasters in other domains. Yeah.
Eric?
Oh, okay. Martha?
Yeah.
Well, I have two questions too. First, did he get divorced? So 7 categories is not enough. Is there a point of diminishing returns, or even a point
Yes.
where there's overfitting?
Yes,
And
there is. And that's a complicated story. And I can give you a paper on it if you're interested.
I would be interested.
Okay, well, give me your
but,
email.
but there is a point at which you're
Yes,
sort
right.
of peaking.
Right. But what you see, if you, I didn't point it out when I showed you those histograms of the number of unique probabilities that people use in 1 year, there was a huge tail. There's enormous individual differences in how much precision people need.
And is there any, if I can just follow up, is there any pattern to that in terms of
Well,
certain kinds
yeah.
of questions need more precision than others, or certain
Oh, that's a good question.
people need more precision?
That's also a long story that I'm sorry I won't be able to tell you here, but certain people do use the probability scale in a more granular way. And guess who those people are? The super forecasters, yes. Right? Yeah.
Well, thank you for the excellent talk. My question is on, we have this, is it possible to use one kind of method, like a probability method, with the one focusing systems, and then use another, like algorithmic machine learning method with another focusing system, and you try to combine those two.
Okay, I think the question's about hybrid prediction models, and it's a great question. It's one we're very interested in. It's one of the next steps that should occur. And actually, IARPA is soon to.
November 14th.
Okay, that's the deadline for that one. And yes, talk to David if you're interested.
Yeah, because that's also some kind of example.
Right. Yeah.
Just a follow-up to Barry's question, and it's sort of a logical question. What you showed is that by degrading the number of options,
Yeah, rounding to.
you hurt performance.
Right.
Have you ever, I don't think the inverse is necessarily accurate. Have you ever shown that by increasing the number of choices, they actually get better? Because there, as you said, there are a lot of reasons that people are better, and it's
Right.
not just the number of
Right. Well, I think the way that we would do that correctly would be to use a randomized control trial where we randomly assign people to groups, conditions where they have different degrees of uncertainty to use,
Right.
and then compare.
So has that ever been done?
We haven't done it yet,
Okay.
but it's in the works,
Okay.
and it should be done. Yeah.
So you said a few times in the talk that the scoring rule needed to be simple, but you have these massive amounts of data. You have these massive amounts of data that you've collected over the course of the trial through the prediction markets, and it would seem that if you let a more complicated algorithm do it, it should be able to do a better job scoring than a simple scoring rule. So why simple?
I think you mean aggregation rule rather than scoring rule.
Yeah, I do mean aggregation.
Okay, all right. Well, we had really complicated ones too. And those did remarkably well. And this too is a big, long story that I'd have to tell you about at another time. Or give me your email and I'll send you papers.
So take one more question and then we can continue.
Okay,
Our-
great.
Our drinks. Let Andy.
Oh, okay.
Thanks. It's a common finding in social psychology that if you let people organize themselves within groups, they make decisions that are worse than if you just let them make decisions individually. So I realize there are lots of ways in which, lots of things you can do in groups that allow them to make better decisions. So I'm wondering if you have any insight of what went on in those groups that allowed them to make better decisions than the individuals.
Well, we have Superforecaster here in the front row, but I'll give you my intuition and then let her say something if she wants. We worried about herding and groupthink and all the negative things that occur in groups. And I really was putting my money on independent forecasters being better than teams. But this is a virtual team. They're working on the internet, and they're coming in at different points in time. And it's really hard to be a big bully in a situation like that. That's my hypothesis. Do you have any others?
I think that's absolutely right. I think that the asynchronous quality of the environment reduced a lot of the typical biases that tends to intervene. And but I think from a team-to-team basis, I mean, there were disparities certainly between different team cultures. Our team was very atypical in that we spoke the least to each other,
Yeah.
whereas other teams were very gregarious. So there was a lot of room for variance there, I think. But I think the primary issues were the ones that Barb cited. That not being able to forecast when you wanted, at the time that you needed, and knowing that you're all trying to work towards a goal, which is we're all competitive and want to win. So that played a key role.
So there was a wonderful balance between cooperation and competition here. You cooperated with your team members, but you were competing with all the other teams. And that was a nice added touch as well. And I guess we'll stop here, so thank you very much.
Let's thank Barb one more time.